Hi, my name is Jarek Lusek. I'm a business development manager for high-speed data converters at NXP Semiconductors. Today, we wanted to introduce you to a simple setup based on Xilinx Kintex-7 KC705 running together through FMC connector with our 14-bit dual-channel 200 megasamples per second ADC based on JESD204B interface. So before we get into the more details about the setup of the demo, let me talk about the benefits that the serial interface JESD204B brings to our customers. The first main benefit is the complexity of the implementation reduction. So basically we can cut down on the number of lanes running between our ADCs or DACs and the digital side like KC705. In this example, per channel you need only one JESD204B lane. So that basically cuts down on the complexity, which translates also to the cost reduction because you can reduce the implementation area on the PCB board. You can also reduce the number of PCB layers, so that's another cost benefit. With the cost benefit also comes reliability improvements because we're cutting down on the number of IOs because we're reducing the number of lanes. In addition to that, we improve the electrical performance because you're cutting down on the number of lanes that can be coupling to each other. The EMI and RFI performance improves, which basically improves the signal integrity. You can also extend the signal reach. So JESD204B calls for 25 centimeters compliance between the analog and the FPGA. Also, you can switch between bit resolutions because this is a serial interface. If you decide to switch, let's say, between 16 or 14 bits down to 12 bits, you don't have to relay out. If you have pin-to-pin compatible type of ADC, which we do, you can switch basically from high bit to low bit or from low bit to high bit. So these are some of the key benefits that already existed within even JESD204A. JESD204B brings additional features and benefits. One of the key benefits is increase in the bandwidth. So now you can transmit the data, digital data, up to above 12 gigabits per second. So that's an increase basically from 3.1 to 5 gigabits per second that existed for JESD204A. You have an addition of key feature which is deterministic latency, and the deterministic latency basically guarantees that the data latency for each channel or device stays fixed between the power-ups and the steady-state operation. So this is a very key benefit for multi-input, multi-output, multi-channel type of applications. Then another feature that JESD204B brings is harmonic clocking. So we integrate within our NXP, within our ADCs and DACs, harmonic clock dividers to simplify the system clock implementation. And then finally, NXP integrates so-called multi-device synchronization feature within our ADCs and DACs. This is where you can sample synchronize and make a phase coherent type of signal transmission between the different channels and different devices. And finally, we work very closely with Xilinx during the IP development on interoperability and functionality testing, so this way the customer ends up with a working solution. So let's go now to the demo portion of this video.
Hi, my name is Brad Loisel. I'm application engineer for high-speed data converters with NXP, and I'm going to step you through the Xilinx KC705 JESD204B based demo. The demo consists of the Xilinx KC705 Kintex-7 based development board, which has two FMC connectors. The high pin count connector is used to interface to the NXP ADC1443D200 demo board. There are two ADCs on this board for demonstrating multi-device synchronization, and here on the board you can see the JESD204 high-speed serial lanes. The demo setup is relatively easy. There are two signal generators required. One signal generator sources the sample clock, in this case 153.6 megasamples per second, and that goes to the clock input of the ADC1443 demo board. The second signal generator sources the input frequency along with a bandpass filter, and that's injected into one of the channels of the ADD converter. There are two ADD converters. In this demo, only one ADD converter is being illustrated. The data is digitized by the ADD and sent over the JESD204B lanes at 5 gigabits per second, down through the FMC connector to the Kintex-7 FPGA. The data is collected in the Kintex-7 FPGA, and the raw data is then read back through the FMC connector over the USB interface to the laptop. The laptop also controls both the Kintex-7 board and the ADC demo board via the USB connections. There's a LabVIEW interface that's used to control the ADC board and configure it, and also to display FFT results. On the LabVIEW interface, the user can configure the part number, the input clock frequency, the sample clock frequency, and the number of points in the FFT. In the middle of the display is the FFT in quasi-real time. And on the right-hand side, the dynamic performance is displayed, such as SNR and SFDR. This LabVIEW interface is provided free of charge to all NXP demos. Shown here is the Xilinx ChipScope tool. This tool is used to download the bit stream to the Kintex-7 FPGA, and it's also very useful as a debug tool for debugging the FPGA code.
The relevant JESD204B markets and applications are wireless infrastructure radios, multi-channel, radar systems, software-defined radios, and any other multi-channel communication equipment. Additional demo boards with JESD204B and FMC connector. DEC1628D1G25, which is a 16-bit dual-channel 1.25 gigasamples per second DEC. BIDA57 form-fit FMC module, developed by FIDUS, based on ADC1443D200. All the relevant information can be found on nxp.com/dataconverters.